baby, time to shake and bake. Well, more shaken than bacon, but ooh, bacon. Focus!
5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Hey everyone, welcome back to the STEMulus. I'm Steph, and today we're doing another topic talk. Since everything is currently on fire out here in California, I figured I'd do a discussion about the other natural disaster I've had to adjust to dealing with out here, earthquakes. That, and my dad is about to do a unit on them in his high school science class. Hi Dad! So what exactly is an earthquake? Well, it's what you feel when two chunks of earth slide past each other suddenly. The place where the two chunks slip and slide is what we call the fault line. The place under the surface of the earth where the quake originates is called the hypocenter, and the location directly above it at the surface is what we call the epicenter. You've probably heard that term a lot on the news when talking about an earthquake. So what exactly causes earthquakes? Well, if you cut into the earth like it was a big spherical cake, ooh, cake. Focus! If you cut into the earth like it was a big spherical cake and pulled out a slice, what you'd see is that there are four main layers: the inner core, the outer core, the mantle, and the crust. The crust and the mantle make up the outermost layers of the earth, but the layers aren't all in one piece. Instead, the outer skin of the earth is made up of many different pieces, also known as tectonic plates, that slide past each other and bump into one another. Since the plates have rough edges, the edges catch on each other, so it's not like two smooth surfaces moving past each other. Instead, they build up energy until they can overcome the friction caused by the rough edges, and instead of smoothly sliding past each other, they suddenly jolt by, which is what we feel when the earthquake happens. The energy that was stored up while the two plates were stuck and trying to slide past each other radiates outward when the sudden slip happens, creating seismic waves that act like ripples you see when you drop a pebble into a pond, but in 3 dimensions. When these waves reach the surface, that's when we feel the shaking and the quaking. Earthquakes are measured by a device called a seismograph, which works by sitting on the ground with a heavy weight that hangs freely. When the quake occurs, the string or whatever may be suspending the weight absorbs the motion, which causes the weight to swing back and forth. At the bottom of the weight, a pen moves across a rotating drum of paper to record the earthquake. The graph generated by this motion is called a seismogram, and it helps scientists determine the size or magnitude of the quake. When we talk about the magnitude of an earthquake, we're talking about measuring the earthquake comparatively with a reference earthquake that's considered the standard. For each number the earthquake goes up on the scale, the magnitude is 10 times greater. So a magnitude 3 earthquake is 10 times stronger than a magnitude 2, and so on. Seismograms also come in handy when determining where the quake originated from. Scientists are able to do this by looking at the P waves and the S waves generated by the quake. P waves travel faster than S waves, like lightning travels faster than thunder. And like lightning and thunder, you can tell how close you are to an earthquake by looking at the difference in time in between the two. Did you ever see lightning and then count the Mississippis in between that and when you hear the thunder to determine how far away it was? The same principle can be applied to the P and S waves. S waves always follow P waves, and the larger the distance between the waves, the further you are from where the quake originated. Another way to think about this is going back to the ripples on the pond analogy we used earlier. When you look at the ripples right where you drop the pebble into the water, they're very close together, but as you get further and further away from the spot where you drop the pebble in, the farther apart the ripples become. Using triangulation, scientists are able to look at these ripples and determine where the earthquake originated from based on the distance between the P and S waves. So is there any way we can predict earthquakes to help people prepare? Unfortunately, there's no reliable way to predict exactly when an earthquake can happen. Scientists may know that a fault is due for a quake, but as far as they know, it could happen tomorrow or in the next 1,000 years. However, there are a lot of different organizations working on developing early warning systems that provide a heads up once the quake has already started. This may not help people right at the epicenter, but a few minutes or even a few seconds can buy someone enough time to duck under a table, get away from furniture that could tip over on them like a heavy bookcase, or even just get outside. Surgeons or people working with heavy machinery or dangerous chemicals can also stop work and avoid potentially catastrophic injuries. While prediction still isn't an option for us, early detection systems can still go a long way in preventing injury and saving lives. So that brings us to our question of the day. Have you ever experienced an earthquake? If so, what was it like? Let us know in the comment section down below. If you want to learn more about earthquakes, I'll include the links to all of my sources in the description down below, along with links to all of my social media and my Patreon page, so feel free to check those out. If you're new here and you find my terrible jokes and geekery tolerable, hit that subscribe button and turn on notifications so you never miss out on any of my future content. I'm always looking for suggestions for future episodes of Topic Talk, particularly from educators like my dad to use in the classroom. So if you've got a STEM-related topic you want to know more about, submit it in the comment section down below or on any of my social media pages using the hashtag Topic Talk, and I just might make it into an episode. Also, I will be at Geek Girl Con in Seattle this weekend, so if you're in the neighborhood, come stop by and say hi and talk science with me. I love meeting you guys in person. It's really, really cool. But with that, I hope you all have a wonderful rest of your week. Stay well, stay awesome, and I will see you next time.